All right, let's get started here. So good evening, everyone. I know it's a Thursday evening, almost end of the week, of what is, I'm sure, an exhausting week. What we thought we'll do is, by the way, the name says Ola, and you would have seen Ola cabs outside. So our customer here, Praveen from Ola in India, have changed the name from Ola cabs to Ola. So that's why it reflects as Ola. And we thought we'll talk about a story of what Ola does back in Asia, in India, where we are from, and their use case of use of storage and EBS at scale, and you will understand why this scale comes from. So before we get started, a quick round of introduction. Praveen, you might want to introduce yourself?
Yeah, hi. Myself Praveen Jain. So I work as the Director of Engineering at Ola Cabs, and I take care of infrastructure and platform at Ola.
Okay, those are his connects there as well. I work at Amazon Web Services. I've been here for a little more than 6.5 years. I used to be a solutions architect, and I now manage a team of solution architects back in Mumbai. So let's see here. How many of you are interested in history? Just a joke. So what we thought was, I'm not going to bore you with a history class, but just people who may be new to EBS or may not know the entire history of EBS, we thought we'll just spend a few minutes to kind of take you through the roadmap of how it's been before we kind of tell you what and which pieces sort of fit in this puzzle, which is use of EBS by Ola and some of the latest and greatest features that were released this year. So back 11.5 years ago, in 2006, we obviously had one of our first services launched, which was EC2, and along with that, we had something called as ephemeral storage or transient storage, right? Which is really local storage on the server or the hypervisor beneath the EC2 instance. That was sort of the only storage form that customers had 11.5 years ago. So it was a bit rudimentary. It was still very, very useful, although it was transient for keeping logs and other stuff. Obviously, in a couple of years, we realized that customers gave us feedback that as their use cases increased to include, let's say, more persistent use cases, right? They needed some kind of persistent storage, and that's where sort of the equivalent of a hard disk drive or magnetic EBS was released, which was over the network, unlike ephemeral storage, so attached to EC2 instances. And this sort of stayed put and solved a lot of use cases for multiple customers for many, many years. We continued progressing, but then we heard that people need fast disks that are faster, low latency, more throughput, more I/O, and so we started releasing SSD disks as a service in the EBS space. So we started off in 2012 by releasing a SSD disk which was specifically directed at giving you more IOPS, right? So it's also called IO1, where you could essentially just click a button, go to the console and say, this is the number of IOPS I want for this EBS volume, and you would be charged a fixed fee for the number of IOPS provisioned. We also then introduced a more flexible offering, which was still SSD, but somewhere in between, where you could have elasticity in that SSD volume, which meant that at certain points of day when you had bursts, the IOs could actually increase or give you some amount of flexibility. And the way here the IO to sort of storage ratio worked was that you would get 3x the amount of IOs versus the amount of storage that you're provisioning, right? So you sort of had something in between as well to give you flexibility. You then had the IO1 storage, which was, you could have fixed IOPS, and then you had magnetic volumes. We obviously then recently last year got back into getting hard disk drives in, ST1 and SC1, and this was specifically targeted at workloads which required much more throughput, very, very high throughputs, right? So instances of running Kafka cluster or MapReduce jobs or ETL or log processing and so on and so forth, you would probably use something called a throughput optimized hard disk, which is also called ST1, or another use case where your use case is more throughput driven, but let's say the rate at which you access the frequency is much lower, and there you could use cold hard disk drive, which was SC1. So these are obviously slightly cheaper than, let's say, SSD volumes. So just to do a recap, this was EBS magnetic, what we now call as previous generation. So if you potentially are already a customer using EBS magnetic, you can still use it, but just know that the latest and greatest features and other things may not be added to it because we are obviously focusing on current generation EBS volumes, which is the other 4 that I showed you on during the timeline. And what we're going to talk about towards the second half of our presentation, which is sort of the live EBS modification feature, which is what Ola has been using to solve a specific problem, or elastic volumes as some customers like to call it. That's sort of applicable on the right-hand side, which is with current generation EBS volumes, not the previous generation ones. This, sort of to complete the history class, I guess, or the reiteration, this sort of forms your entire sort of overall storage offerings from AWS. And what's important also is if you look at the left-hand side, data ingestion is no more such a big deal anymore, right? Because we have these plethora of services where you can actually move data. It's one thing to have a storage service. It's another thing to have mechanisms to move data in and out, right? Especially things like Snowball, for example, where you could move terabytes or petabytes of data into and outside of AWS, into these storage services. Right, so now that we're done with our history class, let's look at a couple of quick fun facts. We mentioned that we are from back in Mumbai, in India. I don't know how many of you have been there, but let's look at some of the unique tenets. And I'm saying this because you'll kind of realize later as to what are the problems and challenges that a company like Ola faces and what they're trying to solve. And the core of it is, EBS volumes and storage. And so to start with, to commute in India can be a lot of fun depending on how you see it. If you're commuting by taxis or cars on the road or by public transport, it is extremely challenging and tough, as you can imagine, because during peak hour rush, you basically are one among millions of people. We have regular religious festivals where we have deity immersions on the road where driving or even parking your car becomes almost impossible. We have other popular sports and Bollywood interests in the country, which mean people actually travel across the city for hours to kind of watch these because it's highly popular. And then you have people also commuting across states and cities sometimes by road to visit monuments of historical interest, right? Like the Taj Mahal, for example. So really a varied sort of broad range of requirements that commuters actually need. And so to solve that, we obviously had Ola, and Praveen here is from Ola, as he introduced himself earlier, with a vision where they wanted to kind of reimagine, sort of transport systems in India for millions and millions of people with these problems at hand. And we believe that their vision was probably being much more than a taxi aggregator to really be a sort of app and a engine for millions of customers, commuters that is, to give them much more than just taxis, but anything and everything. So Praveen, you want to just talk about your story?
Yeah, thanks, Shantanu. So we are number one, taxi aggregator in India, and Ola App is India's most popular transportation app. And as he mentioned, like our mission is to build mobility for billion people, basically, in transportation area. Yes, so Ola was founded in Jan 2011 by Ankit Bhati and Bhavesh Agarwal. So it's we have presence in 100 plus cities in India, and we have like 800K to 900K drivers, partners basically, and vehicles onboarded to Ola platform. So our average ETA is 3 minutes for when you book a Ola cab. Though across the cities that we have, right, is an average ETA is 3 minutes, and it's used by millions of customers every day. So some of the Ola app features are like, we have different categories like micro, mini, prime. These categories you can use to book a cab of different size of the cab. Like if you want a small cab, then you can go for mini and micro. If you want a sedan or SUVs or big luxury cabs, then you can go for prime. And we have like Ola Share, where you can pool the ride within the city. So as he mentioned, right, we have like so much traffic problem and pollutions and all, and Ola Share plays a very big role there. And we have Ola Shuttle. So if you want to have a predefined routes from office to home or home to office, and all these things, you can use Ola Shuttle as well. And we have something called outstation. If you want to travel intercity, like say Mumbai to Pune or somewhere else, right, you can book Ola outstation as well. So we have Ola rentals. If you want to book a cab for 2 hours or 4 hours or 8 hours, you can book a cab with rentals basically. So we have something called Ola Select. If you become a Ola Select member, then there won't be any peak pricing, and you will be given the highest priority while allocation, right? So, but our main unique proposition is Ola Play. So what is Ola Play is like in-cab entertainment system. As Shantanu mentioned, like we have like so much traffic problem, and if you travel 10-kilometer distance or something, right, it will take hours basically. So like people in cab, they can use Ola Play to have in-cab entertainment. So it's a advanced car connect platform where you can play music, videos, and anything, shows and all those things. And we are planning like to extend this Ola Play as a workstation. So if you are traveling like longer distance or outstation or something rentals, then you can do workstation as well within the cab, right? So another unique proposition is tuk-tuk, which we call as auto rickshaw in India. So these vehicles are like millions of vehicles are there in India. So if you want like a shorter distance to travel, like 4 kilometer or 10 kilometers something, to get an auto, you have to stand somewhere on the road and ask them bargain and all those things. But we have integrated these as well in Ola app. If you are not getting a cab because of so much demand, then you can go for a tuk-tuk as well for shorter distance, and it is very economical basically. So there is no bargaining anything, it's a fixed charge, and like very economical prices basically. Okay, so another is auto connect Wi-Fi. Once the commuter onboards in a cab, automatically Wi-Fi gets connected, and you can use the Wi-Fi. Right. So we are the first ride sharing company who offered as a cash as a payment. But if you don't want to pay as a cash, you can use Ola Money as a wallet. With Ola Money, it's not just paying the bill for the cabs, but you can do shopping, you can do transfer of money with the friends and family, and you can do mobile recharge as well, basically, right? And other things that we have is something called Otp Multi-Factor Authentication. So there was a bad user experience where customer experience where before he onboards into cab, driver is to start the trip. Right, so we introduced something called multi-factor authentication. So the commuter, once he onboards into a cab, he has to give the OTP. Then only driver can start the cab, or else he can't start the cab. Then there is no fraud in these sections, right? And we have something called book offline. If you don't have 3G or 4G connectivity, like it happens in India, many places, then you can open app offline and you can book the cab through SMS. And it will come wherever you are there, and wherever the geolocation you are there, it will come there and you'll pick it up basically, right? So back to you.
So in a sense, I guess we sort of see Ola just as similar to Amazon in a way, where they're looking at a vision where they would do anything and everything as a service to their commuters and solve problems and just not be a taxi aggregator. And why we're showing you all this is, I assume that, and Praveen will explain this later, is each of these sort of features that he showed is really a microservice in the background with EBS and some of the data source that they have being at the core, which means that they can spin up services very, very easily. One particular example that comes to mind is back nearly 2 years ago, in a place which is south of India called Chennai. We had huge cyclones coming in, and it really went to a point where everything was flooded, including the airports. And this is sort of a picture of the runway where airplanes were flooded and the entire city came to a standstill. And what sort of Ola did was really fascinating. They actually integrated within, I guess, minutes or maybe less than an hour, a service where people could actually book boats on demand to kind of traverse the city. Ola, Praveen, you want to kind of talk through that experience?
Yeah. So since we are in microservices architecture, and this adding categories is a config change. It took minutes in technical perspective to add a boat, but yeah, to get the boats and do operations took hours. It was more of a social service, social cause, where if someone's stuck somewhere in the flood, they can just book the boat, and the boat will come there, pick them up, and make them in a safer zone basically, right? So next is why AWS, right? So we've been with AWS from day one, and as you've seen the scale, right, and the problems that we have and transportation, we've been growing from 2011 like 5x to 10x year on year basically. So they like the scale and demand is like, unimaginable. And like, to fulfill that, we wanted a cloud partner, which is AWS, which fulfills our all the skills whenever required on demand, right? And we have like very less DevOps team, very lean team, where we focus on automating things and all using AWS managed services like APIs and all. And like, all we do almost 30 deployments a day because we are like, user centric. We are localized to market within India, and we have to roll out quick features. As I told, like board features and all, right? These were very quick. So there are like almost like 30 plus or 30, 40 plus deployments we do per day actually. And other things like, has Ola platform, right? We have like hundreds of APIs which serving like, a million plus requests per minute. We are microservices architecture, and within the microservices, right, we are like, multi-million requests per minute, and these are served within very low latencies, and these are scalable basically. That's why how we have made, and they are geo-based, geo-aware. If I want like, one particular pod to be run into one specific geo, then we can do that as well, right? So we use polyglot persistent methodology. So we have like so many data stores in use, like, Elasticsearch, Redis, MySQL, Mongo, Couchbase, Aerospike, name anything, we use almost all. And these why we use is like Elasticsearch, we store all the geolocations of the driver devices. So every 5 seconds it get uploaded into our Elasticsearch cluster, and it when you open an app, you can see the cabs right around, like, wherever you are standing, and that serves from Elasticsearch geo queries basically. And Redis we use for caching purpose, and MySQL for all transaction purpose, and all other data stores has their own unique requirements basically. So to make more user engagement and make personalized experience, we have petabyte scale analytics. We use stream processing, batch processing. Like we use Spark, Flink, and we use MR jobs and all those things. We do deep learning as well, machine learning as well, and these all feedback goes to the app, and that's where you get like different experience for the user. And like we have 24/7 deployment, we are in containers. We use Mesos Marathon as our framework, and we have built our own orchestration layer above that, and scales very well basically. So containers, like we are running like massive scale around like 20,000 containers in a cluster basically, and like all infrastructure pieces like Mesos and things like data stores we manage via Chef cookbooks using OpsWorks. And few of the things that what we in AWS is like EC2, ELBs, which are basic things, and managed services we use Elastic Cache for Redis and Memcache, and we use RDS for Postgres, because MySQL we are hosted as EC2 boxes only. We don't use RDS for MySQL, but only for Postgres. And we use S3 and Spot, EMR, all these things for analytic purpose, and OpsWorks for managing infra. And enterprise support is awesome, where they support us whenever there's a requirement, right? So this is a very high level architecture. It consists of like 400 microservices. Like we have like divided into something called supply, consumers, and booking and allocation, different things, and they are all powered by data stores, right? So either we use MySQL or Mongo or Elasticsearch. They are all different requirements, right? So this is a very small example, right? Like the containers are served by load balancer, and these use data store which load balance via HA proxy for MySQL case. And if you see the Redis part, like we use Elastic Cache, with the primary groups, which automatically shards and replicas happen. And these all data stores are powered by EBS, 90% cases. 10% cases we use ephemeral storage, right?
Right, so when you get at scale, it's easier to manage this at low volume, but at scale, you may want to just create your internal sort of guidelines or methodologies as to when to use which, right? You know there are about 4 or 5 different sort of storage options that you have when it comes to, let's say, block storage. In general, you would obviously, stating the obvious, you would choose SSD type EBS volumes for your RDMSs and NoSQL data stores. And you would obviously use throughput heavy applications like media, in the media space, like encoding and transcoding, or even use cases of big data analytics or data warehousing, you would typically use your throughput-heavy hard disk drives, which is SC1 and ST1. And this is just one of the broad guidelines that we have from the EBS team and based on our customer experiences from the past, which is, an example could be if you need IOPS, you have a use case where you need IOPS to the tune of, let's say, 80,000 or less, and you're okay with, let's say, low single-digit millisecond latency, then you could go for SSD disks, and if it's really, really low to the tune of 1 millisecond or less, then you would probably need to go ephemeral for instance, with an instance type like I2. Similarly for throughput as well, if you have applications which are throughput heavy, you could kind of follow some of these guidelines. Now don't take them exactly literally for every use case. You may want to do some benchmark tests for your internal use cases, obviously. Now, Ola, for the last sort of couple of years, have built their own internal methodology as well. You might want to talk to that, Praveen?
Yeah, sure. So it is a very simple example. So one of the MySQL store that we have is around 15 terabyte. And if I choose like ephemeral storage, then I have to choose like i3 16x large or i2 16x large, I think is there or not. But i3 16x large, if you see 15 terabyte ephemeral, it costs so much. But with EBS, with GP2, if the requirement is GP2, then it costs this much. It is all Singapore-based costing. And but the note is, if you use ephemeral, that means like your durability is less. If the machine gets hung or it gets a stop-start, something happens, like data is gone, and that's where you will end up like adding more replicas. You'll add like more safer replicas where you'll end up paying more basically. That's why we choose EBS for these cases, and like I need not worry about replicas because EBS having very good durability, and I can detach and attach to anywhere and should work basically, right? So, but as I mentioned there last time, right? Like we use ephemeral storage for Kafka purpose, and something which is like I don't want a durability, but I need a higher throughput. I use Kafka for ephemeral for Kafka and Aerospike. So there's one case like MySQL RocksDB. We use ephemeral storage because we need like high throughput reads and writes. We like store all the GPS trail of a driver. So if there is some audit or something required, we can trail like whole logs basically. That's where we use MySQL RocksDB with ephemeral storage. Right? But what are the challenges at peak? As you've seen, right, the peak comes way too often. Like if there's a festival season, then peak comes. If there's a cyclone or something, then peak comes. And it's like daytime there will be like 5 o'clock to 7 o'clock or 9 o'clock. Then like office times, right? There will be peak, so much peak. And to handle those peaks, right? If you see this one example where our disk read per second or write per second, it grows like drastically, right? And earlier, like we had to provision, better IOPS disk and big storage to accommodate these things, basically peaks. I don't know like when peak will come. Peak might come after 15 days or might come tomorrow itself. I don't know. Like I can't like modify earlier where MySQL store of 8 terabyte. I can't add a disk and it will work out for me, right? And rate of data growth is used as I told, like we are growing like 5x to 10x every year on year. And like as I told, like MySQL example, it was just 1 terabyte or 1.5 terabyte like 1.5 years ago. It increased to 15 terabyte within 1 year basically, right? And to predict these growths, right, like I can't like it is like if I put a huge number of disks and thinking that peak will come, then it's not cost effective. That's why we were using LVMs. LVMs like for only data growth part. If the disk size I want to increase, then I used to add more disk and extend the volume basically. But the problem is like if I want more IOPS, it's not possible, right? Because if I am having like 2 disks of GP2, each 1 terabyte, now my requirement is IOPS is required much more, and I want like guaranteed IOPS, then adding an IOPS disk won't help because still your reads happens like across the disk. It will be stripped, right? So that will not give you the performance. In those cases, we used to recycle the box. Like we used to provision a new box with the requirement, and like it's a very tedious job, right? So that's where we ask AWS to come up with some solution.
Yeah, so sometime towards the end of 2016, Praveen and his team sort of incidentally asked us that, would you ever have a service which would allow us to seamlessly, probably live, on the fly, modify EBS volumes and change some of the tenets of it in order to give us, let's say, more throughput, more storage space, or change the type of EBS volumes, both ways, right? Because that was the need of the hour. And we obviously had heard this from other customers as well. And obviously, start of this year, I think it was February, around February, earlier this year, it was 9 months ago, where we came up with this Amazon EBS live modifications feature, or elastic volumes otherwise called, which really allows you to, with a click of a mouse or an API call, go from one EBS volume type to another under certain caveats, which I'll cover, or change, increase or decrease your IOPS, or even increase the storage volume size itself, right? Which becomes super easy for customers, especially when your peaks come too often and you have to do things manually way too often, and this helps that case. Now, there are some caveats and some lessons learned from Ola's use case as well, which we'll cover. So obviously, it's good to have this. You may want to keep a certain set of the way elastic volumes are used and where it's applied, those guidelines in place before you kind of plan it for your organization as it's applicable. If you look at the process, the way the process works, it works in a process of 4 different steps. You first initiate a modify volume command via command line API or from the console, or you could actually automate that, which I'll cover later. It then goes into modifying stage, which is the EBS volume itself, goes into modifying stage, to an optimizing stage, where it does things in the background, to finally being complete, where you see a green on the console saying it's all complete. That is, whatever your end goal was for that volume is complete now and you're good to go. So let's take an example, a very, very simple example. Let's say you want to modify a volume. You had, up until some days ago, a GP2 volume, which is a SSD disk, with 3000 IOPS and 1 terabyte in size, which you thought was enough for your use case, but since suddenly you find that you need to scale higher and you need a throughput IOPS of 20,000 to the tune of 20,000, you need a disk that is 5 times that size, and so you will need to really convert the type of the EBS volume to IO1 SSD, right? So this is like 3 changes that you're making to the disk. What you would do with the modify volume command is give the modify volume command. It will start modifying your EBS volume, and the status will be shown clearly when you query it, or if you see in the console, that will be very clear. This step typically takes just a few minutes to or maybe just a few seconds in most cases, after which it will enter a stage called as optimizing, where it does the main things in the background, which is all the copying, syncing, changing the type, which basically what it's doing is bringing up another volume of the type that you asked for with the numbers in terms of IOPS and size that you asked for, and doing things in the back end, which is transparent to you. During this process, what you'll realize is the performance metrics of the volume, the source volume, and what you're seeing will remain somewhere between what your source was, which was 3000 IOPS and 1 terabyte, to up to 20,000 terabytes. So it'll at least be at a minimum of 3000 IOPS, not less than that, but it's not going to reach 20,000 IOPS immediately, so it'll be somewhere between that, and you'll see a gradual increase over time if the volume is being used, because this is live, so it's doing things in the back end. At this stage, the optimizing stage generally takes a while, depending on your volume size and a couple of other factors. It could sometimes take from a few minutes to even hours, right? At Ola, I believe you all have given your scale some high volume types in terms of having really big volumes. You want to give an example of how you do it and what the time it takes?
Yeah, so we for 500 GB or less than that, if we change the volume modification, it takes minutes basically. But if it's a higher volume, like say 5 terabyte or 8 terabyte, and I want to increase to 15 terabyte, it takes hours. So still you have to plan better basically. So if you have the requirement by tomorrow, my data going to grow, or like IOPS requirement will be more, I have to predict that, and I have to give the modification command. And it has worked till now, no issues happened. But we are waiting for AWS to give us better way of these things, where in bigger terabyte also it should take minutes basically. If it happens, then we can do many things.
Sure. So you might want to plan well in advance, a little bit in advance, if you really have large volumes in the order of double-digit or even single-digit terabytes, because it does take a while to kind of modify that completely. Finally, you will enter the complete stage, where you would see a green signal and everything looks fine. You can probably even test it and see whether the IOPS and storage volume has changed. It will show all those numbers on your console itself. There are certain times, very, very rare, doesn't happen often, but very rare, and it's documented as well, where this could fail, and I'll explain what you would do there. Lastly, after the volume size is increased, remember this is just a physical volume that has increased. You still have, in theory, your operating system file system on top of it, which needs to recognize the increased change of the storage size, if you're increasing your storage size. So you would typically go into, if it's, let's say, a Linux operating system or a Linux EC2 instance that you're running, give a command like good old Linux system administrators to kind of resize that volume to kind of extend to the new volume size which you have increased the physical volume to. And so if it's ext3 or ext4 file system versus XFS, your commands would vary accordingly as well. It's interesting, Werner, our CTO, says is that if you think that you're automated enough within your DevOps team or your IT organization as an enterprise, a true acid test for that is, as a Linux administrator, are you SSHing into your Linux server very, very frequently, right? And if you are, then you're not automated enough, right? Let's say this is one of the tasks where you can't automate this. You'll still have to log in and to some extent run this command. You could script it up as well. Now, as I was mentioning, this process works beautifully well. Ola has been using this for the last 8-9 months, and at their scale, it works well. There are certain very, very rare cases where you would probably get a failed status at some stage. In that case, do not panic. What you can do is actually just give the modify command again, and then restart the process, and it should work fine. And if you're really having issues, you can obviously contact support, but in general, we haven't seen this failing too often. It's just some very, very rare cases. Some other caveats to sort of keep in mind, stating the obvious again, volume size reduction. So if you have, I don't know, 5 terabyte volume, and for some reason you don't want to pay for 5 terabytes because the use case has changed to a point where you just need a 1 terabyte volume, you obviously can reduce the size using the EBS live modification feature because you can't reduce volume sizes. There are some complications there. You could obviously spin up another volume which is smaller, sync up all your data to the new volume, and then make the switch. But you can't do that live on the fly using EBS live modification feature. As I was mentioning towards the start of my presentation, there are these the previous generation EBS volumes and new generation. EBS Magnetic, which was released in 2008, does not support the EBS live modification feature, which means that if you have an EBS Magnetic volume as of today, you'll have to convert it to another volume before you can start using this. So it doesn't work in these two cases. Additional caveats to be aware of, if you have modified a volume, doesn't matter what size and what you have modified it to, you will have to wait generally a minimum of 6 hours before you would like to modify that same volume again. So if you have an instance where you would like to modify the same volume up and down in terms of IOPS, let's say, on the same day, 6 hours is the minimum wait period before which, 6 hours after completion of the first instance of modifying that volume, after which you can re-modify that volume again. And you can do it any number of times throughout the span of the life cycle of the volume. It's just that the time gap between the two modifications need to be 6 hours. Just like EBS volumes, there are instances, that is EC2 instances. We have lots of them now, which are previous generation. So some of the previous generation EC2 instances do not allow live modification feature. If you look at M3 instances, for example, interestingly, most M3 instances will not allow a live modification on the fly. You'll have to first time detach and attach that EBS volume. If you are running an M3 medium instance, then this is supported out of the box. If there are other M3 instances in the M3 family but not M3 medium, you'll need to detach and attach once. In terms of AMI and instance support caveats, we just mentioned that you can't use previous generation instances where it's not supported. You'll have to detach the EBS volume, attach it to a current generation EC2 instance, and then start using this EBS live modification feature. And if you have certain instances which had EBS volumes attached before 1st November 2016, then you'll have to reboot the instance, attach and detach the volume, and then this feature will start working. All right, so from an Ola Cap's perspective, before we kind of recap, I would like to hear what next in terms of a journey, both in the AWS side of things and your business.
Sure. So we are working towards having more network optimization to have a seamless customer experience and driver partner experience. And then we are working towards infra side to have our own service discovery, config service, routing platform, because we has a microservice architecture. Currently there is a hop with ELBs and all. We are working towards to have a better service discovery so that there is no hop and it works out of the box. And we are working towards Ola Play to be much better in terms of cab entertainment and all other things, basically workspaces and all. And what we are doing is currently we are investing in data sciences, more on deep learning, machine learning, and make more user attribution where we can do more better engagement for the user to come on the Ola app basically. And yes, so India region, right, it came recently, and we've been in Singapore from day one. We are working towards having a multi-region architecture so that we can come to India region itself for Indian traffic. That will be better for network optimization and lower latencies, right? And as I mentioned, in EBS point, if the time reduces for bigger volumes more than in hours to minutes, right, then we can do the automation such a way that CloudWatch, if I can predict the if there is a traffic pattern changing or some IOPS or something changing, then I can trigger a Lambda function to modify on live basically. And we can do SNS notification to do other things like resizing and all those stuff basically, right? So yes, that's it.
All right, so if I were to summarize this presentation and have key 3 or 4 takeaways from this, what I would say is obviously ensure, given the number of EBS volume types that we have today in the current generation and the choice of ephemeral volumes, right? Ensure that you go the route of horses for courses. We sort of showed a guideline in terms of performance of IOPS versus throughput versus EBS volume type as to when to use which. When you're actually operating at scale and have multiple data stores, et cetera, you will at some point in time need to document certain guidelines for your organization as to when to use which, because it does become useful and cost optimized when you start kind of going really deep. Ephemeral store, as Ola mentioned, even at their scale, 10 to 12% of their data stores still run ephemeral, which is still huge. So do not underestimate the power of that. Certain instance types, new instance types don't have that, but there are a lot of instance types which do have that. So evaluate that and compare that with EBS in terms of both performance, latency, as well as cost, and which one works better. LVM, there have been a lot of Linux administrators at other customers that have had interesting arguments in terms of, we use LVM, so what's the point of EBS live modification if we need to extend our EBS volume size, because it's easy to just add EBS volumes. Well, at scale and at high performance, it can be a pain managing LVM, as Praveen mentioned. Do be mindful of some of the caveats. This is all documented, which I showed across 2 slides in terms of when you are allowed to use EBS live modification feature, the 6-hour window between 2 modifications, the caveats around previous and current generation EBS volumes and EC2 instances. It's all documented, just to ensure that you kind of read through them before you kind of go live with this and start operating this. And lastly, automate, right? As we keep saying this, the philosophy of Amazon or AWS for the last 11.5 years has always been to democratize technology and make it easier for our customers, whether you're a 1-person developer startup or a well-funded organization, to kind of have easy access to technology and get started and make it easier for you. And so with everything after a certain point, you may want to look at automating stuff. And in this case, you could automate by having rules where you take inputs from CloudWatch events, trigger a simple Lambda function, and then automate this entire set of steps of modifying an EBS volume versus doing it by hand. Which you can see with certain customers, they have a very, very lean DevOps team and managing a large infrastructure and deployments at scale. So do use the automate feature. There's a blog or by Jeff Barr, and this is included in documentation as well, where we have actually pasted a sample Lambda code that you can actually get started with if you're interested. Or you could write one on your own right from scratch. The storage portfolio is increasing. We saw that at the beginning. There are lots of new trainings and sessions that happen throughout this week, including hands-on labs. We are trying to get more and more training labs across the globe in this space. So do watch out. If you're really interested for a training for your team or hands-on workshops, just reach out to us through various channels, and we'll be more than happy to help you. That's it for now. We are slightly early, but happy to take questions. Thank you.
use RDS for Postgres, you said, yes?
Yes.
So why not MySQL?
So we have so many requirements, we've been in MySQL with EC2 EBS only from long time, and as I mentioned, I don't think there's a live modification RDS supported earlier. Basically it came recently with EBS elastic volumes, but you have backups and all that happens, but we were in the alters and all that happens, right? It used to be very painful for us with RDS. That's why we always choose with MySQL with EC2 EBS volumes.
So the newer regions, whichever are coming, they don't have any instance which has ephemeral storage. So because if you are saying that ephemeral is good, at the same time, new regions, they don't have any instance.
Yes and no. I'll have to look through the mapping in details. I believe some of the newer regions like BOM, which was launched last year, about 14 months ago, does have a few instance types with ephemeral still. The latest one in Ohio and others I haven't checked really, but that's a good point. So I'll have to look through the sort of list of seeing which regions are the ones with no instance at all with ephemeral. Or any instance at all? Okay, Mumbai does have, let's speak offline, I'll actually list down, but yeah, with Canada and etc., that's a good point, yeah. Yes, sir.
Seems like a lot of what you've been doing is mitigating the fact that there are limitations associated with individual block volumes. Are you thinking about moving to EFS when it becomes available in the regions that you operate on?
So EFS, the
EFS,
shared
personally, my experience with EFS is it won't scale with IOPS basically. So if you have so much operations and IOPS requirement, EFS won't scale in that case. So EBS is perfect fit when it comes with guaranteed IOPS, and ephemeral, as mentioned, is great for IOPS throughput, but durability is a factor. Okay.
All right, looks like there are no more questions. Well, thank you. Happy to stay offline for another 15 minutes and take questions offline. Thank you.